Hi and welcome to the Mode Math and Science. Previously, we looked at the laws of indices and we looked at three specific laws. We looked at the laws of addition, we looked at the subtraction laws and the zero index law. Now, question 1 to 5 is actually dealing on addition and subtraction law. So let's quickly take this one before we continue with the other laws of indices. Question 1 says 625 is equals to 5m. Now 625 is equals to 5m. We must look for a number that must equate this. We must bring this 625 into an index notation. So how do we convert 625 into an index notation? We quickly look for the factors of 625. So looking at 625, we actually find the factors. 625 does not end with 2, doesn't end with any even number. Obviously, it would not be divisible by 2. It does. When you want to divide by 3, you add all the digits. So 6 plus 2 is 8, plus 5 is 13. Obviously, it cannot be divided by 3. The next factor, prime number we're looking at, is 5. Now, because it ends in 5, it means it can be divided by 5. So we divide by 5. 5 in 6 is 1. Remainder 1, we'll take it over, it becomes 12. 5 in 12 is 2. Remainder 2. 5 in 25 is 5. 5 in 12 is actually 2. Remainder 2. 25. 5 in 25 is 5 again. 5 in 25 is 5. Remainder nothing. So we know that if we take 5 in 5 is 1. 1 times 5 times 5 times 5 times 5. So is equals to 5 raised to the power of 1, 2, 3, 4 raised to the power of 4. So it means that 625 is equals to 5 raised to the power of 4. Obviously, we can actually say that it implies that 5 raised to the power of 4 is equals to 5 raised to the power of n. Now, because the base is the same, it also means that the powers must be the same for it to be equal. So it means that our m is equals to 4. 9a minus 6 times 4a raised to the power of 8. Now, the law we are going to use is the first law, which is the addition law. The addition law says that a raised to the power of x times a raised to the power of y is equals to ax plus y. Now, we can decide to write 3, 9 in index notation. And 9 in index notation is 3 raised to the power of 2 multiplied by a minus 6 times 2 raised to the power of 2 multiplied by a raised to the power of 8, which is equals to 3 raised to the power of 2. Let's put like terms together, times 2 raised to the power of 2 times a raised to the power of minus 6 times a raised to the power of 8. So obviously this does not have the same base. So it's still going to remain as 3 raised to the power of 2 times 2 raised to the power of 2 times this is of the same base. So you apply the addition law, which is a raised to the power of minus 6 plus 8. So we have 2 raised to the power of 2 times 2 raised to the power of 2 times a raised to the minus 6 plus 8 is equals to 2. So we have simplified it in this form in index notation. Let's look at the third question. Is 25 times 5 raised to the power of 3. Very well, we know that 5 times 5 is equals to 25. So we can write this as 5 raised to the power of 2 times 5 raised to the power of 3. Once again, we apply the first law, which is the addition law. 5, 2 plus 3. So So we have 5 raised to the power of 5. Take a look at question 4. Question 4, 36t raised to the power of 8 over 12t raised to the power of 6. If you are going to write this in index form, 36 is 3 raised to the power of 2 times 2 raised to the power of 2. Now, 3 raised to the power of 2 is because 36 is actually 9 times 4. So, obviously, 3 times 3 is 9, 4 is equals to 2 times 2. So, I use that notation over there. So, 3 raised to the power of 8 all over 12 is 4 times 3, which is 2 raised to the power of 2 times 3 times t raised to the power of 6. Now, we're going to apply the laws of subtraction here. So, obviously, raised to the power of 2 minus 1. The first one times t raised to the power of 8 minus 6. So it's equals to 3 raised to the power of 1, t raised to the power of 2. This is which is equals the same as 3t raised to the power of 2. Question 5 is 4ab3 divided by 3ab. Now, these two terms, which is the coefficient of term, the first term and the second term, we are going to separate them and then treat them separately. 4 divided by 3. Now multiplied by a has actually one as its index, minus 1 as its index in the other term, times b raised to the power of 3 minus 1. So we have 4 all over 3, 1 minus 1, remember it is a raised to the power of 0, times b raised to the power of 2. Now remember that our 0 index law actually says anything raised to the power of 0 is 1. So we know obviously that we have 4 all over 3 times 1 times b raised to the power of 2, which we can simply write as 4 all over 3 times b2, 4 all over b2 all over 3. In the product law, we have a raised to the power of b into c. This is actually termed the product law. And the product law says if you have that, you have a, b times c. So if we look at the second question, we discover that if you have y raised to the power 4 into 3, what it means is that you have y raised to the power of 4 times y raised to the power of 4 times y raised to the power of 4. If you apply the additional law to this, you have y into 4 plus 4 plus 4, which will give you y raised to the power of 12. And it's the same thing as saying, if you apply the product law now, we will see if it gives us the same thing. Y raised to the power of 4 into 3 is equals to y 3 times 4. Give us y raised to the power of 12. Fractional indices. Now, when we talk about fractional indices, we are talking about powers written in fractions. For example, a raised to the power of 1 all over 2. 1 all over 2 is the power of a, but it's actually written in fraction. And so, most times when we have our numbers written in this form, what it means is that we are talking about the square root of the base. A raised to the power of 1 all over 2 is the same thing as saying this is the square root of A. So if you have this particular index notation, it implies that it is the square root. What if we have A raised to the power of 1 all over 3? It simply means it is the cube root of A. A raised to the power of 1 all over 4 is the fourth root of A that we are looking for. So when we have A raised to the power of 1 all over 2, we know we are looking at the square root. If you have A raised to the power of 1 over 3, we are looking at the cube root. If we have 1 all over 4, we are looking at the fourth root of A. On and on like that. What if we actually have the inverse law? Now, if we talk about the inverse law, we are saying that A raised to the power of 1 minus 1 is equals to 1 all over A raised to the power of 1. The negative sign tells you that the base is to be written in the inverse form. So we call this the inverse law. So if you have A raised to the power of minus 3, it simply means 1 all over A raised to the power of 3. So you can write that Ax minus x is equals to 1 all over A raised to the power of x. So we look at the inverse of our fractional laws. So let's look at the inverse of the fractional index. If you write a fractional index like this, which is A raised to the power of minus 2 all over 3, we remember that whenever we have the minus sign in front of the index, we're talking about the inverse. So we know it's 1 all over A. Now, all over 2 over 3. That's the first thing. But further on, A raised to the power of 2 over 3 is fractional indices. So we put it in perspective, it becomes 1 all over cube root of A, all raised to the power of 2. So if peradventure we are to find 8 minus 2 all over 3, we know very well that we are going to write it as 1 all over 8 cube root all into power 2. So we also know that this is equals to 1 all over 2 over 3 all raised to the power of 2, which is the same thing as 2, 1 all over 2 raised to the power of 2. So it's actually 1 all over 4. The seventh question says m raised to the power of 2 all over 3 all into 6 raised to the power of 6. Now we discovered that the first thing we realize is that the term m raised to the power of 3 is actually a fractional index. Raised to the power of 6 says we can apply the product law as well. So we are going to first of all apply the product law immediately. So we are going to say this is m 2 all over 3 times 6. Look at this. What comes to your mind? You can cross out the numbers. The index, now we are going to 3 in this 1, 3 in this 2. So it makes it 3m raised to the power of 2 times 2. It becomes m raised to the power of 4. So you don't have to go through the stress of trying trying to first of all treat this index as a fractional index, then comma. So just apply the product law immediately. Here we have the eighth question is 18/50 raised to the power of half. Already we know that this is a fractional index. 18/50 into raised to the power of half. We know that we are looking for the square root of 18 all over 50. So let's try to find the factors of 18. 18 is 2 into the power of 1 times 3 raised to the power of 2. 50 is 2 into the power of 1 times 5 raised to the power of 2. So if we look at these, 2 cancels out 2, and then we are looking for the square root of 3 raised to the power of 2 over 5 raised to the power of 2. So we know that our answer is 3 all over 5. So this brings us to the end of the laws of indices and the fractional index.